Okay, this is the video tutorial for lesson 7.4, and we're going to start looking at factoring quadratics. And we're going to start first of all by looking at tiles, which some groups have already done this in the previous lesson as well. So remember, when we start off with our big squares here, the x squareds here, because it's x times x, and then these rectangles are x's, which are x multiplied by 1. So down the side, it shows you this would be x plus 1. And then similarly, as this would be the same length as a rectangle, this would be x. And as this is the same width as a square, these would just be 1. So 1, 2, 3, 4. So this would be the factor x plus 4. Similarly, then, this would be x plus 1, 2, 3, 4, 5, 6. This would be x plus 6 here. And this time they have not given us anything. So this is x plus 3. And this would be x plus 2. Now, on the other questions, it did ask you for the total area. So this would be x squared. I have 5 rectangles here, so this would be 5x, and 6 little squares, which would give me 6. And if you check from the unit from last time, if you multiply x plus 3 times x plus 2, you do actually get x squared plus 5x plus 6 as well. We're going to skip through that one, and we're going to get straight into our questions. So what we're going to do this time is, normally we're given the 2 factors and then we work out what the answer is, which is this area model here. This time we're going to do it in reverse. We're going to find the answer, and then we've got to figure out what the factors were that multiply together to do that. Now, one of the key things we're looking for to do for this is, well, part of it's kind of easy. To make x squared, I know this is going to be x times x. So really what I'm trying to find is what goes here and what goes here. So the 2 things together must multiply together to make 10. So this is why I've got factors of 10 written down on the side here. I certainly know that 1 times 10 gives me 10. And I also know that 2 times 5 also gives me 10. So how do we decide which is the correct answer? Well, there's one piece that we haven't used here, and it's this. We know that there must be 7 x's once we've finished. So if I add my 2 numbers together here, so this last part is really important. It tells you what 2 numbers multiply together to make, but it also tells you what you're going to do with those same factors. So I need numbers that multiply to make 10, but add to make 7. And I'm hoping you can see from 2 and 5 that that would be what I'm looking for. So 2x and 5x. Now, if you didn't notice from those previous questions as well, when we were writing down our factors, we start with like x and then plus 4. So it's always like an x, and then it's always a number. And that's going to be the same thing when we're actually doing this as well. Now, the fact that it's 5x, you might be able to see pretty quickly then that it's actually 5. Now, what we're really doing here is we're actually doing the GCF. So this row here, you can see that they both have an x. So that's why I start with x. Here, they don't both have an x, but 5 and 10 are both in the 5 times table, which is why this is 5. X squared and x, the lowest of the exponents is x. That's why I have that there. And for 2 and 10, I know that they're both in the 2 times table. So that would be plus 2. Notice that when we used to do these with the grids as well, we used to add these terms together. So notice that this matches up with this, which is really important. And once I have this, I can actually figure out what my factors are. Now, it might be tempting at this stage just to say, oh, look, it's just the number of x's, and I can just write this straight down. And oh, look, it's just the number of x's. Now, that might be true for these first questions, but that's not going to be true for all the questions. So we really want to thinking about the GCFs here when we're working these out. But certainly for the x squared, there's nothing wrong with putting x times x is x squared. And that's the only thing that's going to give us x squared at this point. Later on, when we move into more complicated questions like 6x squared, then that might not be true. It might be 6x times x, but it could also be 2x times 3x. But for right now, x squared is definitely x times x, so we can fill that one in. And that's what the final grid finishes looks like. And then once you've got those 2 factors, you can write them next to each other, which is exactly what we had in Unit 6. We had this, and we had to work out this. So Module 7 is the reverse. We got this, and we have to get back to the original question. Of course, once you have the answer, you can draw the grid and check, do you get back to this as your little mechanism to make sure you get the correct answer. So this time, I'm focusing on this last part again. It says plus 12. So I know that it has to multiply to make 12, and I know it has to add to make this middle number here, which is positive 8. So for 12, I know I can have 1 times 12. Notice how I'm kind of going through these in order as well. So 2's going to 12 6 times, so 2 and 6. 3 is going to 12 4 times. And after that, it goes 4 and 3, which is the same thing. So I'm going to stop at this point here. Now I want to add them together and make 8. And I think we can see that it's going to be 2 and 6. So I'm going to put 2x and I'm going to put 6x. Notice with this being x squared, I know this is x and x, so I'm going to do that. For this row here, the GCF of 2 and 12 is just 2, and the GCF for 6 and 12 is 6. If it's not obvious, you can use your Desmos calculator as well, meaning that the answer is x plus 2 and x plus 6, as you can see here. Our last example, this time we've got a much bigger number. We have 60. So sometimes this can be a real problem as we're working through. So 1 and 60. Now I might want to check as I go through, is this right? If I add these together, is that going to give me 19? Well, no, that's going to give me 61. 2 times 30 gives me 60. Of course, you can do 60 divided by 2 on your calculator to find it's 30 if you're not sure. If I add those together, I get 32, so it's not that. 3 times, if you're not sure, do 60 divided by 3, and it will check. It will tell you what it is. If you get a decimal, then it just means it's not a factor as well. So 23, and you can see we're getting closer to this 19, so we're almost there. And 60 divided by 4 is 15. And I think we found the one that we're looking for. Yep, 4 add 15 gives me 19, so this is the one I'm interested in. So it doesn't matter which way around you fill these in, whether you fill in the 4x at the top or the 15x, doesn't make any difference. The only difference that happens is the factors get listed the other way around, but that's perfectly okay. So to make x squared, I know this is x times x. 15 and 60 are both in the 15 times table. And 4 and 60 are both in the 4 times table. So my answer would be x plus 15 and x plus 4. Just like you can see here. Now, there are some questions for you to try as well, and you might want to pause the video, work through the Desmos activity itself, and the answers will be coming up in a second if you want to see how well you did. One thing I will make you aware of is there are multiple answers here. So once you've worked out, if you think the answer is x plus 1 and x plus 2, you would have to click 2 answers here. So questions where it says select or apply normally suggests that there is more than one answer for these. So I'm skipping through the questions. And there's 4 to try. And then there's the answers if you want to see them. So 2 numbers that times to make 8 and add to make 6 is 2 and 4. And then the GCF of 4 and 8 is 4. And the GCF of 2 and 8 is 2. And you can see the answer. 15, there were these combinations, but it's 3 and 5 because we want to add to make the middle number, which is 8. Number 3, a few more factors for 20. No factor for 3. If you do 20 divided by 3, you get a decimal. So that's why there's a gap here. But 4 add 5 gives me 9. So I know that's the combination that I want. And for the last one, 1 and 6. And therefore, you can see the answer. Oops, I actually have the wrong one circled here as well. I have 5 circled, but clearly it should be 1 and 6, which is 7. Now, the next ones, I've done one slight change here. If we go back to these questions, we had a plus at the end, but all these middle terms were positive. So this time I'm going to look, what happens if the middle term is negative? Now, actually, it's pretty similar. We're going to start off exactly the same. We're still adding our numbers together. But this time, rather than trying to get 12, I'm trying to get negative 12. Now, for 1 and 20, if I add those together, I get 21. So I can see it's not this combination. For 2 times 10 is 20. And 2 add 12. 2 add 10 gives me 12. So this is kind of close to the answer, but obviously I don't want 12, I want negative 12. So instead of putting 2x and 10x here, what I'm actually going to do is I'm going to switch it around, or I'm going to switch the sign. I'm going to put negative 10x and a negative 2x. Now, remember, if you multiply 2 negatives together, that also gives you a positive. So that's the other possibility when we're doing these questions. They could be, if they end with a positive number, it could be we pick 2 positive numbers, or it could be we pick 2 negative numbers. So this is kind of the clue for us on this one. As I'm trying to get negative 12, negative 2 add negative 10 does indeed give me negative 12. And then I can fill in the GCFs from here. So the GCF of negative 10 and 20, remember, if you type it in Desmos, it will say 10, but as the first term is negative, you would also fill in a negative here, so x minus 10. We know this is x times x, obviously given as x squared, so I'll fill that in. And the GCF of negative 2 and 20, it would say negative, it would say positive 2, but we know it's negative because of the leading negative here. And you can see the answer there just as we had a second ago. So just one example this time, because obviously it's very similar. You can work through the slides. You might want to pause the video at this time. Otherwise, we're going to go straight to the answers. So my first question, factors of 6. And this is where people can get a little careless with their answers. People can sometimes pick 6 and 1, noticing that 6 take away 1 gives them 5, which is definitely true. But we're adding our numbers together here. So it's definitely 2 and 3. And I don't want to pick 2 and 3 because that gives me 5 when I'm trying to get -5. If I make them both negative, then that would certainly work for this question here. And I just realized that's supposed to say x minus 3, not x minus 10. So apologies for that. Let me cross that out. And that's obviously something I'll need to fix before I release this. For our second one, I'm trying to get 16. So these are my factors, but I'm trying to get 10 or -10. 2 add 8 definitely gives me 10 because I'm adding them together. As I want -10, I'm just going to make them both negative. And for the last one, 18, trying to make 9 or really -9. 3 add 6 gives me 9. But as I'm trying to get -9, I'm going to make them both negative. Oops, and there was one more at the end. I apologize. I missed that one. Sometimes when there's just one factor, that can sometimes be confusing if you don't think of it. So 1 and 5, 1 add 5 gives you 6. And then from there, we can continue. And I can see that this is a total mess right here. The GCF of 5 and 6 is 1. And the GCF of, oh, this is totally a mess. This is supposed to say 5 down here. So let me fix this on the fly as we're going through. So we said that we want, we want 1x and 5x. So the GCF of 5x and 5 is 5. And the GCF of 1 and 5 would be 1. So we have x plus 5 and x plus 1. And then for our last section, we're going to look what happens. What if this last number is negative? And I've put plus or minus here because sometimes it's positive, sometimes it's negative, and we'll look at both cases. So this time we're still looking at factors of 8, but the difference is this time we're going to subtract to try and make the middle number. So for 8, I could have 1 and 8, or I could have 2 and 4. Now, if I do, I don't know, I always normally do biggest take away smallest. If I do 8 take away 1, I get 7. And if I do 4 take away 2, I get 2. Now, notice from the order that I said this, I said I want to do 4 take away 2. So I can fill it in like this. Now, my x squared again, once again, just going to fill in x and x. GCF for -2x and -8. As it's negative, I know it's going to start with a negative, and it's -2. GCF for 4 and -8 is +4. And then there's my answer, x plus 4 and x minus 2, whichever way around you want to say those two. And I actually did it the other way around as I wrote my answer this time. It doesn't make any difference. You still finish up with that same answer. Now, this time I made it, I've kept the -8, but this time I made it -2 rather than +2. So if I do 4 take away 2, obviously I get 2. So I'm close to the answer. So all I'm going to do is I'm just going to switch the order. I don't want to do 4 take away 2. I want to flip it over. I want to do 2 take away 4. So 2 take away 4. And that will give me that -2x that I'm looking for. X squared, I'm just going to fill that in straight away as x and x. And then my GCF for -4x and -8, it will say 4 if I use Desmos, but I know it's -4 just because of that leading negative sign. And the GCF of 2x and -8 is just going to be 2. So x plus 2 and x minus 4, whichever way around you want to think of it. Now, these can often cause problems when there's no number here. So we can see it's factors of 6, and I can see I'm subtracting it. But when we don't see anything here, sometimes it's tempting to think it's 0. So actually in the question, I wrote down the fact, actually it's not 0 at all. It's actually 1 for this question. So 1 and 6, 6 take away 1 is 5, not what I'm looking for. I also know 2 and 3 is going to work, and 3 take away 2 is 1. So I have exactly what I'm looking for here. I am looking for +1, and I got +1. How did I do it? I did 3x, and then take away 2x. And then now I can do that GCF again. So GCF of -2 and -6 is going to say 2, but really we know it's -2 because of the leading coefficient. GCF for 3 and -6 is going to give me -3. And of course, our x squared, as always, is just going to be x times x. So x minus 2. And That's supposed to say positive 3. I apologize. With this being 3 and negative 6, this should be 3. And there you can see the answer. Doesn't matter if you switch the order around, you still get exactly the same answer at the end. And our last question, kind of a trick one. This one is the only one that's not been a trinomial so far. We just have 2 terms here. Don't have any x's in the middle. I'm actually going to add that back in. I actually think of it as 0x. Sometimes that helps us to do this question. So for 25, I know it could be 125. 2's not divided into 25, neither do 3's or 4's, but 5's do. And actually, that's the important part for this question. It's going to be some number when you multiply it by itself gives you this number, because then when I subtract them, I'm going to get 0. 2 numbers have to be the same if you want to subtract them to make 0. So these are always going to be square numbers when it's written like this. So it'll be something like x squared minus 100, for example, 10 and 10. So as I'm filling this in, remember I'm subtracting here. So I'm doing 5x, take away 5x. And then as I work through my questions here, the GCF of this would be negative 5. The GCF for this would be positive 5. And I know that x times x is going to give me my x squared. So x minus 5 or x plus 5. So it's the same thing terms. It's just that one's positive and one's negative. And that one's called a difference of squares, and it's one that's worth looking out for. The reason it has that name is x squared is a square number, and obviously 25 is a square number as well. And difference just means subtract. So difference of squares is a very special one. You probably don't want to write the factors out when it's like this. Just think about which number multiplied by itself gives you this number, and then you can use that to help. Just like before, there are some practice questions. So you can try them on Desmos, or you can pause the video and go try them. We'll talk through the answers now. So time to make numbers at times to make 14. So I came with 1, 14, 2, and 7. I tried 3, doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work. If I get to 7, then I know I've gone back to this. I would try each one as you go along, because if you find the answer, you don't need the rest of the factors anyway. So 14 take away 1 is 13, 7 take away 2 is 5. So I want positive 7, and I want negative 2, and then I can get my answer from there. 14, I'm subtracting to get negative 13. So I know straight away, I wrote down 2 and 7, which might have been a waste, because if I try 14 minus 1, I get 13. Notice I don't want 13, I want negative 13. So switch the numbers around, do 1, take away 14, and then I'll get this negative 13. Plus x, remember this means that it's 1x. And then the numbers that multiply to make 12, you can see down the side here, and I stopped at 3 and 4. 4 take away 3 gives me 1, which is what I'm looking for this time. I'm looking for positive 1. So I stuck with positive 4 and negative 3, and then I can get my answer from there. Then we got the difference of squares one, x squared minus 9. One with 2 terms. If we can just think which number multiplied by itself gives you 9, you can come up with 3 and 3 pretty quickly. Make one positive, make one negative, because 3 take away 3 gives us 0, which is what we're looking for. That's why you don't see any x's here. And that does it for factoring trinomials. Really focus on this last number, because it provides you with a lot of information. It tells you which numbers you're going to be multiplying together, but it also tells you whether you should be adding or subtracting those factors to make that middle number. And knowing that x squared gives us x and x, really we're just looking for those 2 numbers. Once we can find those 2 numbers, then that's going to help us to find those answers. That does it for this video.